Hi, welcome back, Algebra 1 students. We're going to be doing the lesson on exponential uh, properties today. Our goal today is the students will use the properties of exponents to transform expressions for exponential functions. So we're going to be using properties of exponents, and we're going to be transforming expressions. So we're going to be using the properties of exponents to transform our expressions. So before we get started today, I want you to go to page 286 and work on questions 1 through 10. Make sure that you're good with them, that you understand them. If you don't, if you have questions, contact your teacher and get those clarified before you move on with this lesson. So once you've completed that, I need you to turn to page 288 in your Springboard book. And we're going to start talking about the rules of exponents. So in this, we have a table that's going to try and show us what we do when we multiply exponents. And you'll notice that all the ones that we're multiplying, we have bases that are already the same. Bases are the same, bases are the same. These rules only work when the base is the same. When the bases are different, that is going to be an Algebra 2 idea. So we're not worried about that in Algebra 1. So the example they already give us is they want us to see that 2 to the second power times 2 to the fourth power gives us 2 to the sixth power. And you may remember this from 8th grade, but I want to make sure that you understand why this is true. So here, if we have 2 to the second power, we could rewrite that as 2 times 2. So this 2 times 2 right here represents 2 to the second power. And we're going to multiply that, which is why we have another multiplication sign, by 2 to the fourth power, or 2 times 2 times 2 times 2. So what we have here is 2 squared times 2 to the fourth power. And then it's showing us that we can rewrite that even one more time by just counting how many 2's we're multiplying and making that one easy to use for, expression. So we have 1, 2, 3, 4, 5, 6 2's, which means this is 2 times itself 6 total times, or 2 to the sixth power. Then we can move on and do 5 cubed times 5 squared. So the first question is, how else could we rewrite 5 cubed? And we can rewrite that as 5 times 5 times 5. And we're multiplying that by 5 squared, so we're going to multiply that by 5 squared, or 5 times 5. So now we just need to look at this and see how many times did we multiply 5 by itself. And we did that 1, 2, 3, 4, 5. So if we're multiplying 5 by itself 5 times, we can rewrite that as 5 to the fifth power. Now we get a little more algebra-ish, and we're not going to use numbers for our bases, but we're going to use exponents. We're going to use variables. So this time we have x to the fourth power. And even though it's not a number, there's nothing different about this. Math works the same whether you're using numbers or you're using variables. So we're going to say x to the fourth power is also known as x times x times x times x. So this is x to the fourth power times x to the seventh power. So we're going to do this 7 times. 1, 2, 3, 4, 5, 6, 7. So we have x to the fourth power times x to the seventh power. And we want to know what is another way that we could write that. So we just simply count how many x's do we have. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 x's. So we can rewrite this big giant monster as x to the 11th power. Then in our last example, we have a to the sixth power, which is going to be a times a times a times a times a times a times a squared, or a times a. So again, we just need to count how many of these do we have. We have 1, 2, 3, 4, 5, 6, 7, 8 of them. We have 8 of them, so we have a to the 8th power. And the question right now is, do we notice something that's happening as we go from the original product and ignore the expanded form? I'm assuming you understand that that's more of an 8th grade concept. So what's happening as we go from the original product to the single power over here? Is there something that happened that we notice a pattern when we did 2 squared times 2 to the fourth to get 2 to the sixth? 5 to the third power times 5 squared to get 5 to the fifth power? Is there something that's happening? And for most people, it's pretty obvious, and we can make a rule for this. All we're doing, and if you go to number 7, this is where we get our rule, and this is called the product of powers property. The product of powers property. And what the product of powers property says is that if you have two bases that match with exponents, that you can get their product by adding those exponents together. So a to the power of m times a to the power of n equals a to the power, and I'm going to write it over here because that little box is not really big enough, a to the power of m plus n. And it's really important that you know this rule. This is a very important rule. So what I'm going to suggest is that you go back in your notes and often the side in your book somewhere and write product of powers property. And make a note to yourself that that means anytime I see a to the power of m times a to the power of n, that I really want a to the power of m plus n. Because this rule is going to be easy for you to mix up with another rule that we're going to have shortly. So keep this on hand somewhere. So we have this rule. And this is one of our exponent property rules. We've got a whole lot more rules to go. So on page 289, if you go look at this chart, instead of multiplying them, now we're going to divide them. And you see that we're doing kind of the same process. This time we're doing 2 to the fifth power divided by 2 squared. So we have 2 times 2 times 2 times 2 times 2 divided by 2 times 2. And this is only different in the sense that if you go back almost to 5th grade, what happens when you have a number on top of a fraction and on bottom? And the answer to that is that they eliminate each other. So one of these 2's killed one of the 2's on top, and you can see that that happened right here. And the other 2 killed another 2, and that happened right here. And now we just want to know, what do we have left? We have 1, 2, 3 of them left, so we have 2 to the third power. So we can keep doing this. We have 5 to the 8th power, so we're going to write that 8 times. 4, 5, 6, 7, 8. All divided by 5 to the 6th power, so we're going to rewrite that 6 times. 1, 2, 3, 4, 5, 6. And again, if you have number on top and bottom, they eliminate each other. They kill each other. So this 5 is going to take out this one will take out this one, and we will keep on slaughtering 5s until we run out of 5s on either the top or the bottom. And now we've eliminated everything we can, and we're left with 2 5s on top. So we can rewrite 5 to the 8th power divided by 5 to the 6th power as 5 squared. Now we have a to the third power, so 3 of these guys, a times a times a, divided by a to the first power, which is just a single a. And again, if you have a number on top and bottom, they kill each other. So this a is killed by this a, and we're now out of things that can eliminate. So we have 2 a's, or a squared. Then final one on this, we have x to the 7th power, so we're going to make 7 of these little x's. So 1, 2, 3, 4, 5, 6, 7, and we're going to divide it by x cubed. And again, if it's on the bottom and the top, they can eliminate each other. So this x kills this x, this one kills this one, and this one kills this one. And we just have to count how many do we have. We have 1, 2, 3, 4 left over. So we have x to the 4th power, x to the 4th power. And again, just like with the multiplication, ignore this expanded form. This is the math of what's happening. But is there something going on that's kind of obvious? So here we had 2 to the 5th power divided by 2 squared, and we got 2 cubed. Here, 5 to the 8th power divided by 5 to the 6th power, and we got 5 squared. What's happening in this pattern? And we're going to make another rule about this. And this rule is called the quotient of powers property. And this one says that a to the mth power divided by a to the nth power equals a to the power of m minus n. So I'm going to write that over here again because this box is kind of small. And look, it is really important on this one that you keep these in the correct order. The exponent on top must go first. The exponent on bottom must go second. With the product of powers property, it really doesn't matter because addition, the order doesn't matter. But with subtraction, the order matters a lot. So make sure that the number on top goes first, the exponent on bottom goes second. But here the rule also says that a cannot equal 0. And the question is, why? Why can a not equal 0? And hopefully you obviously know that you cannot divide by 0. Well, you can divide by 0, you just get an infinite number of correct answers, so it's useless to us in math. So we don't like to divide by 0, we get an infinite number of solutions, so we actually say that there is no solution if you're dividing by 0. So if your base is 0, this is a no-go, you cannot divide it. So again, if we go back to those notes that we're taking in the side of our notebooks, we have another rule that we should keep track of. So this time, we need to know what is the quotient of Powers property. And you need to keep this handy. So we're going to say that a to the power of m divided by a to the power of n equals a to the power of m minus n. Make sure you have all of this somewhere handy so you can reference it when we start doing the work. More rules. I know you love more rules, right? So now we're going to have something else that happens, something a little weirder. So we're dividing again, and the rules don't really change. And as you can see, we have 2 to the 5th power, so we wrote 2 5 times here. We have 2 to the 8th power, so we wrote 2 8 times. And we eliminated over and over and over again. But this time, all of our numbers that were left over ended up on the bottom. So up here, when we were eliminating, we weren't really like getting rid of them. We were saying, what is 2 divided by 2? And 2 divided by 2 is 1. And when you multiply by 1, that usually means nothing. So we didn't have to write it in the previous slide. Here, though, it's important that we know that all of these things didn't really just disappear. They just became a bunch of 1s. So here, when we multiply 1 times 1 times 1 times 1 times 1, we just end up with 1 on top. And here, 1 times 1 times 1 times 1 times 1, those aren't going to really do anything. So we're just left with 2 times 2 times 2, and we got 2 to the power of 3. But when we use our subtraction rule, we get 2 to the power of 5 minus 8 equals 2 to the power of negative 3. And the key to this is to understand that these two things actually say the same thing. So let's look at it a little bit more. We have 5 cubed, so 5 times 5 times 5 divided by 5 to the 6th power. And I got a little messy there, but that's all right. So these will eliminate, these will eliminate, and these will eliminate. Now remember, these didn't really disappear. They just became 1s. So 1 times 1 times 1 leaves me with 1 on top. And down here we have 5 times 5 times 5, or we could say 5 to the power of 3. And if we follow our division rules, we have our base of 5 to the power of the top exponent minus the bottom exponent, or 5 to the power of negative 3. And we need to know that 1 over 5 to the 3rd power is the same thing as 5 to the power of negative 3. So here we're going to keep going. We have a times a times a, because this is a cubed, divided by a to the 8th. So we're going to have 8 of these guys. Isn't it fun to write all these out over and over again? So we have 1, 2, 3, 4, 5, 6, 7, 8 of them. Again, we're going to eliminate. We don't have nothing left on top. These all became 1s, so we make sure we call that a 1. And then we have 1, 2, 3, 4, 5 of these guys left. So we get 1 divided by a to the 5th power. When we follow our division rule, we keep our base, which is a, and we do the top exponent minus the bottom exponent, and we get a to the power of negative 5. 1 over a to the 5th power is the same thing as a to the power of negative 5. And then one last one, and then we'll just make a rule out of this. We have x to the 4th power divided by x to the 10th power. You thought writing a to the 8th power was a lot of fun, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We're going to eliminate. Again, these things didn't actually disappear. They're 1s now, because x divided by x, no matter what the value of x is, any number divided by itself is going to give you 1. So we have 1 left on top, and we have 1, 2, 3, 4, 5, 6 of these puppies left on the bottom. And so we get 1 over x to the 6th power. And now if we follow that division rule, we keep our base of x, because both of these have a base of x, to the power of the top exponent minus the bottom exponent. and we get x to the power of -6. So again, this is all fun, and this is important because this is the math. This is what's happening to make the rule. But we can look at just these outer columns and kind of figure out what the rule says. And so we are going to have a new rule that is called the negative power property. The negative power property. And what the negative power property says is that 1 divided by a to the power of n is equal to a to the power of -n. So let me write that a little bigger. So 1 to the power of a divided by 1 divided by a to the power of n is equal to a to the power of -n. Basically, if you have an exponent in the bottom of a fraction, you can move it to the top by making that exponent negative. So we're going to have a new rule that is the negative power property. And all it says is 1 over a to the power of n equals a to the power of -n. It's really important that you keep these rules handy. All right, let's do another rule. This is actually my favorite rule. This is the rule that I trick my students with all the time. So go to page 291. We have a new chart. And here we have 2 to the 4th power divided by 2 to the 4th power. And it seems to some of us that this would be obvious, but this is the question with exponents that's probably missed the most often in my class. So 2 to the 4th is the same thing as 2 times 2 times 2 times 2. 2 to the 4th, 2 times 2 times 2 times 2. And when we start eliminating from the top and the bottom, we notice that we eliminated everything. We didn't really eliminate things because 2 divided by 2 is 1, not nothing. So everything on the top became 1s, and everything on the bottom became 1s, and 1 over 1 is 1. But when we follow our division rules, 2 to the power of 4 minus 4, what is 4 minus 4? Well, that's 0. So we actually get 2 to the power of 0. And this is going to be a really cool rule that 75% of my students get wrong when I test it. So here, when we have 5 to the 6th power over 5 to the 6th power, we're going to say 5 6 times, divided by 5 6 times. And we're going to eliminate, doop, 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 and everybody eliminated everybody, right? So up here, these actually became 1s. They didn't really disappear, so we have 1 on top. And all these became a 1, and we have 1 on bottom, and 1 divided by 1 gives me 1. And when we follow our subtraction, our division rule, we have 5 as our base. The top exponent is 6 minus the bottom exponent, which is 6, and we get 5 to the power of 0. It's really important you know 5 to the power of 0 is 1. 2 to the power of 0 is 1. So let's see what happens when we use variables. So a cubed divided by a cubed. So a to the 3rd power, we have 3 a's. A to the 3rd power, we have 3 a's. We're going to eliminate. These guys did not actually disappear. They just turned each other into 1s, because when you divide something by itself, you get 1. So this becomes 1 over 1, or just 1. And then we're going to do our division rules, and we have a base of a. The top exponent is 3 minus the bottom exponent, which is 3, and we get a to the power of 0. And this is interesting because we get a new rule out of it. And if anything, you know that I love new rules, right? So we have what is called the zero power property rule. The zero power property rule says that a to the power of 0 is 1. Anything, no matter what it is, if I put it to the power of 0, it is 1. If I say 7 to the power of 0, that is 1. If I say x to the power of 0, that equals 1. If I say x squared, y to the 7th, z to the 14th, divided by 144 to the 327th power, all to the 0th power. It's to the 0th power. So it equals 1. When you get tested on that, when you see this on the ACT, and this question right here is almost always on the ACT, don't sit there and try and calculate this. It's all to the power of 0. The answer is 1. So let's add this to our rules. We have the zero power property. Zero power property. If I could spell it would help. Property. And the zero power property says that a to the power of 0 equals 1. Any number to the power of 0 equals 1. All right. Let's try this. This is one of the rules. This is one of the things that happens that causes confusion with another rule. So be very careful when you're learning this rule. Go to page 294. And we have 2 squared to the 4th power. And when we say 2 squared to the 4th power, what we're saying is 2 squared 4 times. So you'll see that we wrote out 2 squared 4 different times. And 2 squared means 2 times 2. So this is 2 times 2 for the first 2 squared, 2 times 2 for the second 2 squared, 2 times 2, and 2 times 2. You'll see we have 4 sets of 2 times 2. And so we're just going to count how many 2's we have. We have 1, 2, 3, 4, 5, 6, 7, 8. So this is 2 to the 8th power. Same thing happens here. We have 5 to the 5th power cubed. So we have 5 to the 5th times 5 to the 5th times 5 to the 5th. And we're going to write this out all these times. So we're going to write 5 times 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 5. And I'm going to try and fit this all in here. Times 5 times 5 times 5 times 5 times 5. And we have 5 to the 5th power cubed. 5 to the 5th power has happened 3 times. And how many times did we multiply 5? Well, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 times. So we have 5 to the 15th power. And then here we have x cubed to the 4th power. And what I hope you realize at this point is it doesn't matter if you're using numbers or variables. Math does not change. Math is universal. So x to the 3rd power to the 4th power means x cubed times x cubed times x cubed. And that's going to be x times 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 x. And then again, we just need to count how many x's do we have. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We have x to the 12th power. So this is pretty simple, especially when you see the rule. The thing I need you to be careful of is this is different from multiplying exponents. This is what is called the power of a property, or power of a power property. So in this case, a to the power of m to the power of n is equal to a to the power of m times n. So we have a new rule, and it's called the power of a power property. So power of a power property, let's put it on our handy dandy notes. And it says that a to the power of m to the power of n equals a to the power of m times n. Now here's what I need you to be really careful of, guys. This rule is different from this rule. Here in the product of powers property, we are multiplying the bases. So we have to add the exponents. Here in the power of a power property, we have 2 exponents in the same question, acting on the same base. So we multiply the exponents. What happens when I test this, and it happens over and over again, is you get this question, a to the power of m times a to the power of n, but you do this process. These are different things. Here we have 2 different exponents on a similar base. The multiplication is happening between the bases, though. Here, the exponent is acting on the other exponent. So if it's multiplication between 2 bases, you add. If it's an exponent acting on another exponent, you multiply. And I'm pretty convinced the confusion happens because we're multiplying exponents here in the result. People go, oh, well, we're multiplying exponents, but we're really adding those exponents up here. So please be very, very careful. All right, we're almost done with our rules. I know you love the rules. Now, here we have 2x to the 4th power, and that again means 2x times 2x times 2x times 2x. We're multiplying 2x 4 times. Now, you should remember this from 7th grade. When you multiply things that have numbers and variables, you multiply the numbers separately from the variables. So how many 2's did we have? Well, we had 1, 2, 3, 4 of them. So we get 2 to the 4th power. And how many x's did we have? Well, we had 1, 2, 3, 4 of them. So we just put it to the 4th power. So the result is 2 to the power of 4, x to the power of 4. And if you wanted to solve that, you could. It wouldn't be wrong. We're going to get into that in a minute. So here we have negative 4a to the third power. So that's the same thing as negative 4a times negative 4a times negative 4a. And again, we multiply the numbers separately, the coefficients separately from the variables. So we're going to say negative 4 times negative 4 times negative 4 times all of our variables, a times a times a, because we have 1, 2, 3 of them. So we have 3 negative 4s, so we're going to say negative 4 cubed, and we have 3 a's, a cubed. So we have negative 4 cubed, a cubed. Down here we have x cubed y squared to the fourth, so that's going to be x cubed y squared times x cubed y squared times x cubed y squared times x cubed y squared, which becomes, and this is going to be fun, x times x times x times y, and I'm for sure not going to have enough room, so we're going to have to go underneath it just a little bit, times x times x times x times y times y, times x times x times x times y times y, times x times x times x times y times y. And again, we just need to count how many do we have. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 x's, so we have x to the 12th. And we have 1, 2, 3, 4, 5, 6, 7, 8 y's. And we get x to the 12th power, y to the 8th power. So, make a rule about it. So this rule is called the power of a product property. And what it says is that a times b to the power of m. So again, we have two different bases that are all given one exponent together. So a times b to the power of m is going to be the same thing as a to the power of m times b to the power of m. So again, on our rule sheet, we're going to say power of a product property. Power of a product property. And we're going to say that, how do we word it? AB to the power of m equals a to the power of m times b to the power of m. Please have these 6 rules handy because you're going to need them in just a second. So, why do we need to know all of these exponent rules? And here's the key. All of those rules you learned in 8th grade. There was nothing new there. But your EOC in Algebra 1 goes a little bit deeper. They're going to try and trick you. They're going to ask the question in a weird way to try and trick you out of some of your points. So I'm going to show you how they're going to ask the question, and you're not going to let it trick you. EOC is going to ask the question backwards. They're going to try and trick you. Instead of saying, what happens when I do this, they're going to say, what could have caused this? Or in other words, write an equation that is equivalent to 3 to the power of t plus 2. And the problem is most of us panic. We see that and we go, how would I possibly know an equation that could have led to that? The answer lies in our rules. If we look at our rules, we will see that one of them looks a lot like the question. So here we're asked some base, doesn't matter where it is, it's 3 in this case, but it doesn't really matter where it is, to the power of t plus 2. So some number plus some other number. So look at your 6 rules. Only one of those 6 rules has addition in the exponent. If you look at your 6 rules, only one of them has addition in the exponent. Can't be this guy, that's a negative. This one is subtraction, this one is just a 1. This one is multiplication, and this one has 2 bases with the same exponent. The only one that it matches is this guy right here. So we can use the fact that we know this must be the product of a powers property to answer the question. So let's look a little bit closer at it. This is the powers of product property, and it says a to the power of m times a to the power of n is equal to a to the power of m plus n. And we've got information here. What number in here represents the m in our equation? And the m is placed first in our addition, so it must be this t. So our m is t. And then what number here represents the n in our equation? The n is the second number in the addition, and here the second number that occurs in the addition is 2. So our n value is 2. Well, if we know m and we know n, and we know our base, I probably should have put what is a equal to here. So, and we can go ahead and do that. What represents a? And that's going to be a is whatever number is the base. And in this case, the base is 3. Well, now that we know a and m and n, which we're calling 3 and t and 2, we can take it out of the result and come up with the original question from it. So again, this was a to the power of m plus n. 3 was in the place of a, t was in the place of m, and 2 was in the place of n. So we can rewrite it. Now that we know these values, we can say if the original equation had to be a to the power of m times a to the power of n, well, that means my a value is 3. So I'm going to put 3. My m value was t, so wherever I saw m, I'm going to replace it with t. And my n value was 2, so wherever n was, I'm now going to replace it with 2. So another way to write 3 to the power of t plus 2 is 3 to the power of t times 3 squared. Now, is there something here I could write differently? Sure, I know what 3 squared is, right? What is 3 squared? Well, that's 9. So another way I could write it is 3t times 9. And since multiplication, the order doesn't really matter, I could also write it as 9 times 3 to the power of t. Here's the key when you get tested on this. You're going to get a test that has 4 options, and you have to say which one of these is not equivalent. So if you can turn it from this form into this form, you already know one of your correct answers. And then if you just know, this is like 5th grade math, if you can do 3 squared, you know this answer. And then if you remember your rules from 7th grade that multiplication, the order really doesn't matter even when there's variables, you can reorder it and get this answer. And you just know that whatever the 4th answer is cannot be correct. So let's try another. Here we have 7 to the power of 3 minus x. Which of our rules does this look like? So again, we're looking for a rule that somehow encompasses an exponent with a minus sign. And there's actually 2 of them, right? So it can't be this guy because that's plus, possibly this one because it has a negative in it, possibly this one because it has subtraction, no good, no good, no good. So it's one of these 2, but one of these 2 doesn't really make sense in the context, right? This has 2 numbers, a number minus another number, and this one doesn't. This is just a negative floating up in space. So it must be this one. This is the quotient of powers property. And the quotient of powers property says that a to the power of m divided by a to the power of n equals a to the power of m minus n. So we just need to figure out what goes in what places. If this is my original question and it looks like the end result here, what number is in the place of a? And a is the base, and the base of this question is 7, so a is 7. What number is in the place of m? And in this case, m is the first number in the exponent, and the first number in the exponent is 3. Here's where some people get messed up, so be really careful. That minus sign matches, so this x is not negative. It's just the minus sign that matches the formula. So what's in the place of n? Well, in this case, n is the number x. So now that I know a, m, and n, I can replace it in the original question. I have a, which is 7 to the power of m, which is 3, divided by a, which is 7 to the power of n, which is x. So a valid alternate version of 7 to the power of 3 minus x is 7 cubed times 7 to the x power. So the question becomes, is there another way that we could write this? Is there a different alternative way to write this? Is there something here you can solve? And the answer is sure. What is 7 cubed? If you need a calculator, get a calculator, but I would really rather you went back to the, your 5th grade method. If you didn't know what 7 cubed was off the bat, figure it out. Calculators should not be used as a crutch. They should be used to verify that you did your math right. So 7 cubed is 343. And we don't know what 7 to the x power is because we don't know what the x is worth. So in this case, there's only 2 alternative forms that are reasonable right now. So you could say that 7 to the power of 3 minus x could be 7 cubed over 7 to the power of x, or could be 343 divided by 7 to the power of x. These two are both equivalent to 7 to the power of 3 minus x. All right, let's try one more together, then I'm going to give you 6 that you should practice on your own. So here we have 4 to the power of 2 plus q. And the question again is, which rule does this look like? We have 6 rules. Which one does this look like? We have an exponent that has a plus sign. And we already did one like this because there's only one rule that has an exponent with a plus sign. And that's this guy right here. So this must be the product of powers property. So we're going to say a to the power of m times a to the power of n equals a to the power of m plus n. And we just want to know what are the values of a, m, and n. So here, what number is in the place of a? And it's 4. It's the base. And what number is in the place of m? In this case, it's 2. And what number is in the place of n? And in this case, that is q. So now that we know our values for a, m, and n, we can replace, since we know the result, we know the thing that must have given us that result. So a is 4. So we have 4 to the power of m, which is 2, times a, which is 4, to the power of n, which is q. Well, you have an alternative method. This is a valid, correct answer. These two things are equivalent. Or we could do the math. What is 4 squared? And please tell me you don't need a calculator for that. So you could say that it is 16 times 4 to the power of q. This is also a valid alternative version of 4 to the power of 2 plus q. You have to be able to convert between these different forms. The 8th grade stuff is important and you really need to know those rules, but for Algebra 1 you have to be able to use those rules to convert between the original question and the result of that question. So I have 6 questions I would like you to try to answer. Go through these, get the answer you think that they should be. If you think you're right and you want verification, ask your teacher. If you're confused and you have no idea what I did in this, ask your teacher. Ask questions. This is key stuff. When you get to Algebra 2, you have to understand this. It is vital that you learn how to do this now, so when you get to Algebra 2 and when you take the ACT, that you know how to do this. So I want you to do these 3 questions. I've tried to give you plenty of time to write those 3 down. You can always rewind the video a little bit if you need to. And then I have 3 more questions for you. Try to solve them, see what you can come up with all the possible alternative versions. That last one's a little bit tricky, but I have faith in you. Your teacher will give you some additional practice, some things for you to do on your own. Thank you very much. Ask questions. Ask questions.